Graphing rational functions with slant or oblique asymptotes. All right. So I'm going to take my function and look for my overall degree. So in the numerator, it's x squared. Denominator, it's x to the first. So my overall degree is x to the first. So overall degree is 1. 1 is odd. And knowing that's going to help us graph our function. Leading coefficient, 1 and 1 again. So 1 over 1 is 1. And this is positive. So since my leading coefficient is positive, the right hand end behavior is going to be in quadrant 1. And since my overall degree is odd, remember we think odd opposite, the end behavior as x approaches negative infinity is going to be in the third quadrant. Zeros, where the numerator equals 0. So I have a 0 at 1, and it has a multiplicity of 2, which I'm going to mark as even, because if I have an even multiplicity, it bounces off the x-axis. If it's odd, it crosses through. So I have an even at 1. I do not have any holes because none of the factors in my numerator and denominator cancel. Vertical asymptotes is where the denominator equals 0. So we have 1 at -2. And this has a multiplicity of 1, therefore it's odd. Let's talk about my horizontal asymptote, slant asymptote. My overall degree is 1. Since my overall degree equals 1, I know I have a slant asymptote. And in order to find it, I have to find the equation of the line through long division. So the first thing I'm going to do is multiply out the numerator. So that gives me x squared minus 2x plus 1. And then I'm going to divide by my denominator. So to get x squared, I have to multiply by x. So x times x is x squared plus 2x. Remember, I'm subtracting, so negative. So that gives me 0 x squared terms and negative 4x. Bring down the 1. Now to get rid of this negative 4x, I'm going to put x minus 4 so that I multiply that minus 4. Now at this point, I do not have to worry about finding my remainder. At this point, my remainder does not matter because all I need to do is get the equation for my line, and I've gotten the equation for my line. So my slant asymptote is at y equals x minus 4. All right, let's graph this. Okay. All right. So I need to have a 0 at 1, and it is even. So I'm going to write myself a note of that so that when I get to graphing and I get to that point, I can remember what I need to do there. I have a vertical asymptote at -2. And it is odd. Again, going to be important when I get to graphing. And now for my slant or oblique asymptote, I need to draw I need to use the equation for this line to draw the line. So y-intercept -4, slope of +1. All right, that got a little crooked. All right, so again, remembering my end behavior. My end behavior has to go towards my slant asymptote. So my end behavior has to go towards this line. I know that my function needs to end in quadrant 1. Okay. And then I'm going to go down to my 0. It is even, which means it bounces. So it touches the x-axis and then comes back up. And it will continue until my vertical asymptote at -2. This is odd, and I know it's odd because it was to the first power. The first power is what makes it odd, 1 odd. So odd means opposite. So since I'm traveling up here towards positive infinity, that means I'm going to start down here towards negative infinity. And then remember end behavior must go towards the horizontal or slant asymptote in this case, like so. And I just saw that I was a little bit off out of the camera range. So this is going to be the graph for my function. Let's try and get it all on the screen here.